So in the last video, we covered the basics of multithreading, including what threads and processes are, the states of thread, and how to create threads in Java. If you haven't watched that video yet, do check from the I button. Hi everyone, welcome to the official channel of WebOsmotic. My name is Furmani Arif, a team lead with over 4 years of experience, and today we are continuing on our series of multithreading in Java. So let's get started. Today, we are diving into two crucial topics: thread synchronization and race condition. These concepts are essential for managing threads effectively and avoiding common pitfalls in multi-threaded programming. Yeah, don't worry if that sounds complicated. I'll break it down so it's easy to understand. So let's start with the basics. When we talk about multi-threading in Java, we are essentially talking about running multiple parts of the program at the same time. This can make our programs run faster and more efficiently, but it can also lead to some tricky problems if not handled properly. For example, imagine you and a friend trying to write something on the same paper at the same time. It can get messy, right? Yeah, so that's called race condition in multithreading, one of the most common problems in multithreading environment. This happens when two or more threads try to access and modify the shared data altogether. Let's see a simple example. Yeah. So here we have a class called counter, right? Here we have created the variable integer count. Now what we will do, we will create the increment method, and then we will create the one getter method for this. So public void increment, and what this method will do is simply increment this counter by 1. Then we will create getter for this, and it will return the count for us, right? So so now if we create multiple threads to increment this counter, we might run into some problems. Let's see to see this as an action. Let's create a couple of threads that will call this increment method on the same counter object, right? So here we have a class called main. We will create counter is equal to new counter. So here we have the object of the counter. Now let's create the threads. Like we will create two threads. We can say thread 1 is equal to new thread. And let's do one thing. Yeah. So here we will create the for loop, and maybe we can call it for the 1000 time, and counter dot increment. Now let's create the another thread. We will call it thread 2, which will again do the same thing to call the increment method 1000 times. Now let's start this threads. Thread 1 dot start, and then thread 2 dot start. Now once we have started this, let's create the while block, and we can do maybe thread 1 dot join, and then thread 2 dot join, right? We can now simply interrupted exception is fine for us. Made of step press. Now here let's print the value of this count object, right? I mean the counter variable. counter dot get count. Now when we run this, like when we run this, what do you think would be the expected output here, right? Let's see. Yeah, so the output is 1977. That's definitely not the output what we would have expected, right? We were expecting the output for the 2000, as we have incremented the counter for the 1000 times for the each of the threads, but the output is 1977. Let's try again. Let's see what another output we are getting. It's the same thing, and see, this time we got 2000. When running it again, we might get the different output. Yeah, so it is 1729 this time. So as you can see, that's the problem. So how do we fix this? Well, the solution is pretty much straightforward. We just need to make our threads synchronized so they don't interfere with each other, and that's where the synchronized blocks comes in handy. To make our increment method synchronized, what we need to do is to use the synchronized keyword, right? So just to public synchronized void increment, and our problem is resolved. Now let's run this again and see what output we get this time. Yeah, so output is 2000 as the expected. Let's try it again, as we got the output 2000 in previous case also once. Yeah, so it's 2000 again. Let's try one more time just to make sure this isn't just the coincidence. In here again 2000. So as you can see, we are running it again and again, and we are getting the same output, the same expected output consistently. So that's how the race conditions are fixed, and that's the basic of thread synchronization and race condition in Java. By using the synchronized keyword, we can make sure that our threads don't step on each other's toes. If you found our content valuable, do not forget to like, share and subscribe. Looking forward for your feedback in the comment section below. See you soon.